On this Ram 2500HD with the 6.4 gas engine, P0203 may mean the PCM is detecting an electrical problem in the fuel injector 3 circuit. The truck may turn the MIL on, and depending on how the fault shows up, it can run rough, misfire, or have an intermittent drivability complaint. The possible fault areas include the injector power feed, the injector control circuit, connector or terminal problems, wiring, battery and ground issues, injector electrical or mechanical behavior, and only after the rest of the circuit checks good, a possible PCM driver issue. Start with the basic system checks before getting deep into the injector circuit. Then read and record all codes and the captured operating data. Save a vehicle scan report if you may need it later. Look at the captured conditions, the monitor gates, and the setting logic. Then erase the codes and operate the vehicle or system in those same conditions to see if P0203 comes back or the condition is present. For this code, reproduce the operating conditions so the monitor has a fair chance to run. The monitor runs with the ignition on, battery voltage above 9 volts, engine speed below 3000 RPM, and the ASD/main relay powering the injector. The PCM is watching injector circuit continuity and the inductive voltage spike from the injector coil when the magnetic field collapses. Anything that reduces maximum current flow or reduces that spike can set the code, so do not treat this as only an injector part check. Treat it as a complete circuit diagnosis. If P0203 is not active, use the captured conditions and try to let the diagnostic run again under similar conditions. For an intermittent problem, verify that the failure mode is actually present before you tear into the system. Check for related flash updates and bulletins. If nothing applies, wiggle test the harnesses the injector circuit passes through while watching for the code to become active or for scan data to change. A scope can also be connected to the circuit while you wiggle test, so you can look for an intermittent open instead of guessing. For the shared intermittent scope method, back probe and connect the scope lead to the sensor signal circuit, monitor circuit voltage while wiggle testing the harness, and if you cannot watch the scope signal voltage during the wiggle test, set up a trigger to catch the intermittent. Set the trigger for voltage above 9 volts for an intermittent circuit high fault or below 1 volts for a circuit low fault. Remember, heat and vibration can make mechanical and electrical problems appear and disappear. Before focused injector testing, check the battery or batteries for proper charge, operation, and connections. Then identify and check the related chassis grounds. Also check for any battery voltage codes in the ECU. Low battery voltage can cause a code, and poor battery system voltage or poor ground connections can make systems act in odd ways. Handle circuit faults before chasing rationality or performance-style faults. At the injector and related connectors, make sure the connectors are fully seated and locked before disconnecting anything. After disconnecting, inspect for water intrusion and for pushed out, damaged, corroded, burnt, spread, or broken terminals. The preferred test is to scope the whole fuel injector circuit. Use the scope to check the electrical path for opens or high resistance, and to help determine whether the injector pintle is mechanically sticking. Put channel on the battery supply voltage circuit, channel B on the fuel injector control circuit, and channel C with an amp clamp on the battery supply voltage circuit. If it helps, run the same test on another injector and keep that capture as a comparison for current draw and inductive spike behavior. The coil resistance check later is useful electrically, but it does not prove the injector is moving mechanically. That mechanical behavior is checked with the lab scope. On the injector off portion of the pattern, battery voltage should be present on the control circuit. If it is not there, that points toward an obvious open in the path. If battery voltage is present on the supply circuit at the same time, that points toward an open injector coil. When the driver pulls the control side low and holds it low, the injector is being energized. Peak amperage draw will typically be around 1.0 amp when energized. If the control voltage does not pull near 0, think resistance in the control circuit path. If the voltage drops low and then quickly ramps back toward battery voltage, too much current flow with driver protection shutdown or a low side driver failure could be indicated. Low resistance in the injector coil can cause excessive current draw, and the PCM can turn the driver off for self-protection. During phase C, the current should build to peak amperage of approximately 1.0 amp if the circuitry is good. The battery supply voltage should stay constant. If it drops when the injector is energized, suspect resistance in the battery supply circuit. When the injector turns off, resistance in either circuit can reduce both amperage draw and the inductive kick. If the voltage ramps down smoothly without the pintle bump, that indicates a stuck pintle inside the injector. The final off phase is the same as the first off phase, waiting for the next actuation. If you are using DVOM-style testing, check the battery supply to the injector with the recommended circuit load test tool or equivalent as the preferred method. Before using that method, make sure the load test setup and method are understood, including any alternate load test or voltage drop approach available to you. Another acceptable check is to probe the battery supply circuit with a 12-volt test light connected to ground. You can also back probe and monitor supply voltage at the injector while it is commanded on and off. The meter should show constant battery voltage. If there is resistance in the circuit, voltage will drop when the injector is energized. Do not assume a circuit is good just because it has not set a separate circuit fault. A few ohms of resistance in the power, control, or ground path can keep a component from energizing correctly. Next, isolate the fuel injector control circuit and check it for an open and for a short to ground. Use an ohmmeter to check continuity in the control circuit and continuity to ground. The control circuit can also be isolated and checked for resistance or short to ground with the recommended load test tool. Then check the injector coil resistance and compare it to the other injectors if technical data is not available. Fuel injector resistance is typically between 9.0 and 18.0 ohms. Typically, the difference should be less than 10% between the injectors, and during this DVOM coil check, the resistance value should be within 10% of the other fuel injector coil resistance values. This coil resistance check is only an electrical check. It does not prove the injector is moving mechanically. Only check the PCM driver after the battery supply and control circuits both test good. If the scan tool has an actuator function for that driver circuit, back probe the control circuit at the injector and watch voltage while actuating the driver. There should be battery voltage present when the driver is off, and no voltage on the control circuit when the driver is on. If the circuit's tested good, and the voltage is not cycling on and off with driver actuation, the PCM is identified as most likely faulty. After repairs are complete, keep verification separate from the diagnostic testing. Make sure all engine components are properly installed and connected, then erase all codes with the scan tool. If a component was removed or replaced, determine whether a scan tool learn routine applies, and perform it when it is available before verifying the repair. Failure to perform an applicable learn routine before verifying repair may cause the same code or another code to set. If the PCM has been replaced, perform module programming, and after programming make sure the secret key code, VIN, and odometer mileage are programmed. Then operate the vehicle under the monitor conditions for P0203 and verify with the scan tool that no codes have returned. If P0203 returns during verification, check for applicable bulletins or cases. If none apply, pause, recheck the earlier diagnostic path, and avoid guessing. If the code and condition do not return, the repair is complete. The takeaway on P0203 is simple. Prove the condition, check power, grounds, connectors, and the complete injector circuit under load. Use the scope when you can, and leave the PCM driver call until the rest of the circuit has earned it. For more diagnostic training, visit stepdiagnostics.com.